Today, we will be talking about the equality rule for logarithms. The equality rule for logarithms states that if the log base a of x is equal to the log base a of y, then in that case, the argument of the logarithmic expression to the left side of the equation, which is x, would be exactly equal to the argument of the logarithmic expression to the right side of the equation, which is y. Now we're going to do a couple of practice problems to demonstrate why this is the case. So first up, we have the log base 10 of 16 plus 2b is equal to the log base 10 of b squared minus 4b. Now, according to the equality rule for logarithms, this argument right here of the logarithmic expression to the left side of the equation would be x. And according to the equality rule for logarithms, the argument of the logarithmic expression to the right side of the equation would be y. This means that, theoretically speaking, 16 plus 2b would be equal to b squared minus 4b. Now what we're going to do is that we're going to solve to see what b is equal to and then plug it into the equation to see if it works or not. So 16 plus 2b is equal to b squared minus 4b. We're going to move the following two terms, 16 as well as positive 2b, from the left side of the equation to the right side of the equation. Now, the new equation becomes 0 is equal to b squared minus 4b minus 2b minus 16. Because positive 16, when moved from one side of the equation to the other side of the equation, it becomes negative 16. Likewise, positive 2b, when moved from one side of the equation to the other side of the equation, it becomes negative 2b. Now, all we have to do is to combine like terms. So we have a like term right here and a like term right over here as well. Now we have b squared minus 4b minus 2b gives us negative 6b minus 16. Now, what we want to do at this point is to look for two numbers in which their product is equal to negative 16, while their sum is equal to negative 6. And the two numbers would be positive 2 and negative 8. So this can be rewritten as b squared minus, plus 2b minus 8b minus 16. Now, to make myself extra space, I'm just going to erase the top two rows. Now, what we can do is that we can put brackets around here. We can also put brackets around here as well. But with one thing that we got to keep in mind. Because this is a minus right here, if we are to put brackets right here, this will become positive. Because negative 1, just imagine as if there were a number 1 right here. Negative 1 times positive negative 1 multiplied by positive 8b gives us negative 8b. And negative 1 multiplied by positive 16 gives us negative 16. Now we can factor this out even further. So we have, actually I'm just going to write this up here to make more space. So we have b squared plus 2b minus 8b plus 16. Now, what we can do is that in the first set of terms inside of the first set of brackets, the common factor that we can factor out would be the variable letter b. So let us do that. So this will be b times open bracket b plus 2. Now, this part right here, it would be, well, the common factor between 8b and 16 would be 8. So we're going to factor out the 8. So this becomes 8 times b plus 2. Now, all we have to do is to simplify. This will become b minus 8 times b plus 2 is equal to 0. And so therefore, for the first scenario, if this whole entire thing were equal to 0, b will have to be equal to positive 8. For this case to be 0, b will have to be negative 2. Actually, I should say not and, but it will be more appropriately written as or. So now what we're going to do is that we're going to plug it back in to see if it works. So if we were to use positive 8, then this part right here would become 16 plus 2 times 8. 16 plus 2 times 8. 2 times 8 gives us 16, and 16 plus 16 gives us 32. This part would become 8 squared minus 4 times 8. 8 squared is equal to 64. So I'm going to erase this and replace it with the number 64. 4 times 8 is equal to 32. So I'm going to erase this and replace it with 32. And of course, 64 minus 32, this gives us 32. Now let us try it with negative 2. So if b were equal to negative 2, then in that case, this part right here would be 16 plus 2 times negative 2. 2 times negative 2 gives us negative 4. And 16 plus negative 4 gives us positive 12. Likewise, for the argument of the logarithmic expression to the right side of the equation, this portion would become negative 2 squared minus 4 times negative 2. Negative 2 squared gives us positive 4, and negative 4 multiplied by negative 2 gives us positive 8. 4 plus 8 gives us 12. Now, we will do a second and last example. So for the last example, we have the natural log of k squared plus 12 is equal to the natural log of negative 9k minus 2. And according to the equality rule for logarithms, this has to equal to this. It is a must. So therefore, this means that k squared plus 12 is equal to negative 9k minus 2. Putting everything from the left side of the equation to the right side of the equation, this would become 0 is equal to negative k squared minus 12 minus 9k minus 2. Now, as you can see, we have believe right here, yes. So we have negative 12 and negative 2, in which we can combine the two of them together. So combining the two of them together, this becomes 0 is equal to negative k squared minus 9k minus 12 minus 2 gives us negative 14. Now, it's not really desirable to leave k squared as negative because it will be harder to factor it out. And so therefore, what we're going to do is that we are going to make this negative k squared from negative to positive. And to do that, we will multiply both the left side of the equation as well as the right side of the equation by negative 1. So right here as well, here we're going to multiply that by negative 1. Now, at this point, to the left side of the equation, 0 times negative 1 remains 0. Negative 1 times negative k squared becomes positive k squared. Negative 1 times negative 9k gives us positive 9k. And last but not least, negative 14 times negative 1 gives us positive 14. Now, at this point, in order to factor this expression even further, what we need to look for is that we need two numbers in which their product is equal to positive 14, while their sum is equal to positive 9. And it turns out that those two numbers are positive 7 and positive 2. So we're going to have k squared plus 7k plus 2k plus 14. And of course, we can put a set of brackets around here and here as well. And no terms inside of the bracket changes because initially the number that was immediately in front of the open bracket sign were all positive 1, and anything multiplied or divided by positive 1 remains exactly the same. Now let us simplify this even further. So k squared plus 7k, we can see that a common factor that we can factor out is k. So this will become k times k plus 7. And this part right here, the common factor would be positive 2. So this will become positive 2 times k plus 7. Now, this, when simplified even further, this would become k plus 2 multiplied by k plus 7. And of course, all of these are 0. Now, at this point, in order for k plus 2 to be equal to 0, k would have to be equal to negative 2. And in order for k plus 7 to be equal to 0, k would have to be equal to negative 7. So now that we have established that k must be either equal to negative 2 or negative 7, let us plug the two numbers into the equation one at a time to see whether it works or not. So, if k is equal to negative 2, then k squared plus 12 would be equal to negative 2 squared plus 12, in which negative 2 squared, not just the 2 is being squared, but the whole entire thing, including the negative sign, is also being squared. This would give us positive 4. And we're going to add 12 to 4, which will give us 16. And as for the argument of the logarithmic expression to the right side of the equation, we're going to have negative 9 times negative 2 minus 2. Negative 9 times negative 2 gives us positive 18. Positive 18 minus 2 gives us 16. So therefore, this part right here works. Now we're going to try it with k being equal to negative 7. So if k is equal to negative 7, then in that case, for this argument of the logarithmic expression to the left side of the equation, we're going to have negative 7 squared plus 12. Negative 7 squared is equal to positive 49 plus 12. This gives us 61. Negative 7 plugged into k would give us negative 9 times negative 7 minus 2. And so, therefore, negative 9 times negative 7 would give us positive 63. And we're going to subtract 2 from it. And this also gives us 61. And so therefore, for this particular case right here, k is equal to negative 7 also works. And this is the quality rule for logarithms.